Far beyond Neptune, a vast and frozen frontier holds the solar system's deepest secrets. This is the Kuiper Belt, a colossal disk of icy worlds left over from our cosmic beginnings. Within this remote expanse, astronomers have found objects so strange and puzzling they force us to rewrite the story of our own neighborhood. Today, we are exploring 25 of the most mysterious objects ever discovered in this distant darkness. By the end of this journey, you will know the compelling evidence for a hidden ninth planet and understand the true, chaotic history of our solar system. How did a spinning egg-shaped world come to exist, and why is there a ring where physics says a moon should be? Which of these frozen enigmas do you think holds the key to our past? Our journey into the Kuiper Belt truly began with a faint, distant world named Arrokoth. The New Horizons spacecraft gave us our first ever close-up look, revealing a shape that defied simple explanation. It was not a single sphere, but two distinct lobes gently pressed together, a cosmic snowman floating in the black. This strange structure is a pristine relic, a contact binary that formed not from a violent collision, but from a slow and gentle dance in the early solar system. Two separate objects born from the same cloud of dust and ice spiraled ever closer until they touched and merged at a speed slower than a walking pace. They have remained locked in that ancient embrace ever since, a fossil from the dawn of our planetary system. Adding to its mystery is its deep, brick-red surface. This striking color is a chemical fingerprint, likely caused by complex organic molecules called tholins. These tholins form when simple ices like methane are bombarded by cosmic radiation for billions of years, creating the reddish sludge that paints this primordial world. Arrokoth is more than just a strange-looking rock. It is a time capsule preserving the very ingredients and processes that built the planets, including our own. That same New Horizons mission, after leaving Arrokoth behind, raced toward a world that would shatter our expectations entirely. Pluto, once the ninth planet, now reigns as a king of the Kuiper Belt. Its demotion was not a downgrade but a revelation, forcing us to see it not as an outlier but as a spectacular example of the complexity hiding in this distant region. This is no simple ball of ice. New Horizons revealed a stunningly active world, a place of breathtaking geology that defies its frozen location. Vast, flowing glaciers of solid nitrogen creep across a heart-shaped plain, while mountains of water ice, hard as granite in the deep cold, seem to float on this frozen nitrogen sea. These peaks might actually be giant icebergs buoyed up by the denser glacial ice beneath them. This dynamic, shifting landscape points to an even more profound possibility hidden beneath the surface, a global subsurface ocean of liquid water. The evidence lies in the lack of ancient craters and the puzzling orientation of the planet itself. Such a hidden sea, kept liquid by the heat of radioactive elements in its rocky core, would instantly make Pluto a prime candidate in the search for alien life. Pluto's identity crisis was our own awakening, a humbling lesson that the most fascinating worlds are not always the ones that fit our neatest categories. But the discovery that ultimately dethroned Pluto came from an even more distant and massive world. Eris, a name fitting for a goddess of strife, ignited a firestorm in the astronomical community. When it was first spotted in 2005, Eris appeared to be larger than Pluto. This immediately forced a difficult question. If Pluto was a planet, then surely Eris must be one too. But where would it end? The solar system was suddenly on the verge of containing not 9, but potentially dozens of planets. The true nature of Eris, however, proved even more challenging than its size. While it is physically very similar to Pluto, measurements revealed it to be significantly more massive. This surprising density suggests a different internal composition, perhaps a much larger rocky core wrapped in a thinner mantle of ice. Its orbit is a dramatic ellipse, a long, stretched-out path that takes it from the inner fringe of the Kuiper Belt all the way out to the scattered disk over a journey lasting 557 Earth years. For a large part of this immense orbit, Eris swings so far from the Sun that any tenuous atmosphere it might possess would completely freeze, falling as snow onto its brilliantly reflective surface. Scientists believe this surface is likely coated in nitrogen and methane ice, making it one of the most reflective objects in the entire solar system, a shimmering diamond in the perpetual night. Then, as it makes its rare approach to the inner solar system, that frozen veneer may briefly thaw, creating a temporary, incredibly thin atmosphere before the deep cold reclaims it once more. Eris did not just challenge Pluto's status, it forced us to create a new category, the dwarf planet, and in doing so, redefined our entire cosmic neighborhood. The drama of redefinition did not end with Eris. Another world, Makemake, soon stepped into the spotlight. Named for the creation deity of the Rapa Nui people, this dwarf planet was initially seen as a near twin to Pluto, a body large enough to hold onto a blanket of gas. Astronomers fully expected to find a thin atmosphere clinging to its frozen surface. Yet when the moment came to observe it passing in front of a distant star, the results were stunningly silent. The starlight did not flicker and fade as it would if an atmosphere were present. It simply snapped off and then snapped back on. Makemake was bare. This was a profound puzzle. Here was a world similar in size to Pluto, coated in the same kind of frozen methane ices that, on Pluto, readily vaporize in sunlight to create a temporary atmosphere. So why did Makemake appear to be utterly airless? The leading theory points to gravity, or more precisely, a lack of it. While Makemake is substantial, it may be just below a critical threshold of mass and gravity. Any gases that do manage to vaporize from its surface may simply escape into the void, too weak to be held back. Its surface is also incredibly bright and reflective, suggesting its methane ice is relatively pure and fresh, not darkened and processed by solar radiation over time. This could mean the surface is too cold for even the limited atmospheric activity we see on Pluto. The mystery deepened further with a completely unexpected discovery, a tiny moon orbiting this seemingly lonely world. Designated Mk2, this small companion is incredibly dark, a stark contrast to its brilliant parent. Its presence suggests a violent past, perhaps a long-ago collision that blasted a moon into existence while also stripping Makemake of the volatile materials needed to sustain an atmosphere. This faint speck of a moon does not just orbit Makemake, it holds clues to the very event that may have left this dwarf planet frozen and exposed, a king without a cloak in the endless cold. While Makemake presents a puzzle of stillness, another world in the Kuiper Belt spins with such ferocious energy it has torn itself into a new shape. Haumea is a cosmic egg, a world stretched into a vast ellipsoid by its own impossible rotation. This dwarf planet completes a full turn in less than 4 hours, a whirl so violent that its own matter was flung outward, distorting a sphere into a football. This is not a gentle wobble, it is a centrifugal force so powerful it fundamentally reshaped a planet. The mystery of how it achieved such a dizzying spin points to a cataclysmic origin. The leading theory suggests a colossal impact, a strike so direct and violent it set the entire world spinning like a top and blasted enormous chunks of itself into space. This ancient collision did more than just distort Haumea, it created an entire celestial family. 2 small moons, Hioka and Namoka, are believed to be fragments from that event, now locked in a complex gravitational dance with their parent. Even more remarkably, a whole cluster of smaller icy bodies share nearly identical orbits with Haumea, all moving together as a family of collisional shrapnel, a permanent record of a single, shattering moment in the deep past. But the surprises do not end with its shape and its family. The surface of Haumea is coated in a brilliant crystalline water ice. This is profoundly strange because in the constant bombardment of cosmic radiation that defines the Kuiper Belt, water ice should be battered into an amorphous, dull state over millions of years. The presence of this fresh, crystalline ice is a glaring clue that something resurfaced this world. Perhaps the impact that spun it up also churned up fresh material from a warm interior, or maybe Haumea possesses some form of hidden, ongoing geological activity that constantly renews its bright, icy shell. How does a frozen relic from the solar system's birth maintain such a youthful complexion? This spinning enigma is a world of violent history and active mystery, a top wobbling through the darkness, refusing to give up all its secrets. Just when we thought we understood the rules of planetary rings, a small world named Quaoar tore up the textbook. This distant dwarf planet, orbiting far beyond Neptune, holds a secret that has left astrophysicists utterly confounded. Quaoar is circled by a thin, dense ring, a feature we have seen before around giants like Saturn. But this ring is not where it is supposed to be. It orbits at a distance that defies one of the most fundamental principles of celestial mechanics, the Roche limit. This is the theoretical boundary around a planet, the point within which the planet's gravitational tides are so strong they will tear apart any large object, preventing a moon from forming. Outside this limit, where gravity is weaker, loose debris should naturally coalesce into a solid moon. Quaoar's ring, however, sits comfortably and impossibly far outside its Roche limit. According to all our models, that ring should have condensed into a small moon countless millennia ago. Yet it persists as a dispersed band of particles, a cosmic traffic circle where all the cars are ignoring the obvious exit to form a parking lot. So what invisible force is holding this ring together, preventing its own natural evolution? One compelling theory points to the extreme cold of the outer Kuiper Belt. At these frigid temperatures, the icy particles that make up the ring may not be sticky. When they collide, they might simply bounce off each other like billiard balls instead of clumping together, lacking the necessary energy or material properties to accrete. Another, more exotic idea involves tiny shepherd moons, too small for us to currently detect, whose gravitational nudges could be corralling the ring material and keeping it dispersed. There is also the possibility of constant collisions within the ring itself, generating a feedback loop of energy that prevents the peaceful collapse into a single body. Whatever the answer, Quaoar's stubborn ring is a brilliant reminder that the universe often saves its greatest wonders for the places we least expect to find them. Yet even the strange stability of Quaoar's ring cannot prepare us for the path of a world named Sedna. This solitary traveler follows an orbit of breathtaking loneliness, a long and narrow ellipse that carries it on an epic journey far beyond the known Kuiper Belt. Its orbit is so vast that a single year on Sedna lasts an astonishing 11,400 Earth years. For the vast majority of that immense time span, it drifts in a frozen no-man's land, a region of space that should be almost empty. How did it get there, and what force placed it on such a detached and isolated path? This is one of the most compelling puzzles in modern astronomy. The standard model of solar system formation cannot easily explain Sedna. The gentle gravitational nudges from the giant planets could not have flung it so far out without also sending it flying off into interstellar space entirely. Its existence strongly suggests that something else, some unseen influence, perturbed its orbit long ago and trapped it in this eternal loop. This is where the hypothesis of a hidden planet emerges with powerful force. The gravitational pull of a large, undiscovered world, a so-called Planet 9 orbiting far beyond Neptune, could perfectly explain Sedna's lonely track. This theorized planet would have acted like a cosmic shepherd, guiding Sedna into its present distant pasture. Sedna is not alone in this either. Several other detected objects share similar strange, clustered orbits, all pointing toward the same invisible master. Contemplating Sedna's deep freeze also reshapes our understanding of the solar system's edge. It appears to be the first known member of the inner Oort cloud, that vast and theoretical shell of icy bodies surrounding our solar system. Sedna is a scout, a nearby glimpse of that unimaginably distant reservoir of comets. Its very presence tells us that the boundary between the Kuiper Belt and the Oort cloud is not a clean line, but a fuzzy frontier where gravitational echoes from the solar system's violent youth are still frozen in time. What other solitary sentinels are waiting to be discovered in that profound darkness, each one holding a piece of the story of how our cosmic neighborhood was born? The flattened shape of 2014 MU69 was a complete surprise to the New Horizons team. After the triumphant visit to Pluto, the spacecraft raced toward this small, distant object which scientists had nicknamed Ultima Thule. Based on earlier observations, everyone expected to see a classic contact binary, two roughly spherical lobes gently stuck together, much like Arrokoth. The first images that trickled back from the edge of the solar system revealed something entirely different. This was no cosmic snowman. Instead, the larger lobe, Ultima, was profoundly flattened, resembling a thick pancake. The smaller lobe, Thule, was also flattened, looking more like a dented walnut. How could such bizarrely thin structures form and survive for billions of years? This strange geometry directly challenges our models of how the building blocks of planets, called planetesimals, first came together. The prevailing theory suggested these small bodies formed from violent, high-speed collisions that created messy, rubble-pile objects. But the extreme flattening of MU69 points to a much gentler, more delicate process. Imagine two fluffy snowflakes, each a collection of dust and ice, slowly spiraling toward each other. Their initial contact was not a violent crash, but a gentle, almost lazy merging at a speed of just a few miles per hour. This low-energy collision allowed the two fragile piles of material to splat together and retain their flattened forms, rather than collapsing into spheres under their own gravity. It suggests the early Kuiper Belt was a surprisingly calm and orderly place, a nursery where the first planetary building blocks assembled themselves in slow motion. This single, misshapen world forces us to reconsider the very first steps of planet formation, revealing a primordial environment far less chaotic than we ever imagined. What other strange and delicate architectures are waiting to be discovered in this frozen construction yard of the solar system? While Arrokoth and MU69 reveal a surprisingly gentle beginning, other Kuiper Belt objects tell a story of pure chaos. Far beyond the orderly orbits of the classical belt lies a region of cosmic anarchy known as the scattered disk. Here, the icy inhabitants are not peacefully circling the sun. They are the survivors of a gravitational war, flung onto wild, unstable paths by the giant planets in their youth. Their orbits are not neat circles aligned with the solar system's plane. Instead, they are highly inclined, tilted at steep angles, and stretched into extreme ellipses that dive deep into the territory of the giants before soaring back out into the frozen abyss. These are not stable orbits for the long term. They are temporary and destined for further change, a clear sign of a violent past. The prime suspect for this celestial upheaval is Neptune. As the giant planets migrated outward in the early solar system, Neptune's powerful gravity would have acted like a cosmic slingshot, hurling countless icy bodies from the inner Kuiper Belt onto these frantic, scattered paths. But the story may be even more complex. Some of these orbits are so extreme that they hint at additional gravitational disturbances, perhaps from passing stars in the Sun's birth cluster or from the very same unseen planet that guides Sedna. Consider the object known as 2002 TC302. This is a world on a dramatic journey, with an orbit so elliptical that its distance from the Sun varies by a staggering billions of miles. At its closest, it ventures near Neptune's domain, feeling the ice giant's immense pull, while at its most distant, it recedes into a profound and lonely darkness. This constant gravitational tug-of-war makes its path inherently unstable over millions of years. It is a fossilized record of a dynamic and tumultuous era, a time when the outer solar system was a chaotic shooting gallery. Every one of these scattered objects is a refugee from that ancient upheaval, their chaotic trajectories mapping the gravitational battles that shaped our planetary system. What other tales of cosmic eviction are written in their unstable paths, but the chaotic orbits of the scattered disk are not the only anomaly. Deep within the main Kuiper Belt, a different kind of mystery is painted in shades of gray. The vast majority of these distant worlds were a coat of deep brick red, a color we now know comes from tholins, the complex organic sludge created when solar and cosmic radiation bombards methane ice over billions of years. Yet a distinct group of objects stubbornly refuse to follow this rule. They are the gray Kuiper Belt objects, exhibiting strangely neutral, almost featureless spectra. Their surfaces are not painted with the familiar reds and browns, but appear as blank slates of gray. What could have stripped these worlds of their colorful coats? One compelling answer points to violence from the recent past. A collision, perhaps by a smaller body, could have blasted away the old, reddened surface layer, exposing a fresh, pristine blanket of water ice from beneath. Since pure water ice is naturally gray in this context, these objects would appear neutral until radiation has enough time to work its slow chemistry and repaint them red, a process that could take millions of years. The object 2002 UX25 is a prime example of this enigma. It is a large, gray world whose color defies its location. Its dull hue suggests its surface is remarkably young in geological terms, a frozen canvas that has been wiped clean and not yet had time to be repainted by the radiation of deep space. Another possibility is that these gray KBOs simply formed in a different neighborhood of the early solar system. Perhaps they originated in a region that was depleted in the volatile ices like methane that are necessary to create tholins. Without that key ingredient, their surfaces would have always been this dull, neutral gray, telling a story of a completely different compositional history from their red cousins. So when we look at these gray worlds, we are not just seeing an absence of color. We are potentially looking at the fresh scars of a recent impact or reading a birth certificate that places their origins in a part of the primordial disk we have yet to fully understand. They are the quiet outsiders, their muted surfaces hiding tales of either recent upheaval or an ancient, divergent beginning. The silent dance of two worlds orbiting a shared center of gravity is surprisingly common in the Kuiper Belt. Far from being lonely outposts, many of these icy bodies exist as binary or even ternary systems, locked in a perpetual gravitational embrace. The most famous of these is the Pluto and Charon system, which is so balanced that the two worlds orbit a point in the empty space between them, making them more of a double planet than a simple primary and moon. But how do such delicate partnerships form in the first place? In the sparse outskirts of the solar system, where objects are few and far between, the chance of two independent bodies capturing each other through gravity alone is incredibly slim. The density of material is simply too low for that to be a common occurrence. The leading theory points back to the chaotic infancy of our solar system. Scientists believe these pairs were born from gentle collisions or, more likely, from a process called gravitational collapse. Imagine a single, loosely bound cloud of ice and dust slowly spinning. As it cools and contracts, it can become unstable and fragment into two or more smaller clumps that are already gravitationally bound from birth. They begin their existence as a pair, a celestial dance that starts from the very first moment. This makes these binaries pristine fossils, preserving the conditions of the primordial disk from which they formed. Their orbits are a treasure trove of information. By carefully measuring the orbital period and distance between the two bodies, astronomers can perform a cosmic weigh-in, calculating their combined mass with remarkable precision. Even more cleverly, if one object passes in front of the other, creating a mutual event, scientists can determine their individual sizes. Knowing both the mass and the size allows for the calculation of density, a crucial number that reveals the internal composition of these distant worlds. A low density suggests a fluffy, porous structure rich in water ice. A higher density points to a much rockier makeup, hinting at a different origin story within the early solar system. Every time we discover a new binary pair waltzing in the darkness, we are given a direct key to unlock the secrets of its mass, its structure, and the very stuff from which it was made. This abrupt edge to our solar system, known as the Kuiper Cliff, presents a geographical puzzle as stark as a coastline on a map. Out around 50 astronomical units from the Sun, the population of icy objects does not slowly dwindle into nothingness. It plummets. It is as if the cosmic construction yard we have been exploring simply stops, as if someone drew a fence at the edge of the known Kuiper Belt. This is not what our standard models predict. We would expect to find a gradual decrease in objects, a gentle fading as we move further from the Sun's influence, not this sudden, dramatic void. So what could have carved this sharp boundary into the fabric of our solar system? One of the most compelling theories reaches back into the Sun's ancient past, to a time when it was not a solitary star but one of many siblings in a dense birth cluster. Astronomers propose that another young star, in a close gravitational encounter, could have flown by our system. This stellar interloper would have acted like a cosmic thief, its gravity stripping away the outer layers of the Kuiper Belt and stealing a vast population of objects, leaving behind the cliff we observe today. The other leading explanation points to a shepherd still within our own system, the very same unseen planet that might be guiding Sedna. This hypothetical planet 9, with its immense gravitational pull, could be clearing out a vast region, either by ejecting objects from the solar system entirely or by herding them into clustered, tilted orbits that our surveys have not yet fully mapped. This means the cliff might not be a true emptiness, but a line drawn by an invisible hand, a gravitational signature of a world we have yet to lay eyes on. Is the outer solar system a quiet, empty frontier, or is it a carefully managed territory ruled by a hidden giant? The Kuiper Cliff does not just mark a drop in numbers, it marks the edge of our understanding. Varuna spins through the darkness with a rhythm all its own. This distant dwarf planet candidate completes a full rotation in just about 6 hours, a speed that places it in an exclusive club of cosmic speedsters alongside Haumea. Such a rapid whirl creates a powerful centrifugal force, stretching the world into a distinctly elongated shape, much like an egg or a football. But unlike the solid, monolithic structure we might expect from a planet, Varuna is almost certainly what scientists call a rubble pile. Imagine a collection of countless boulders, rocks, and ice chunks, all loosely held together by their own collective gravity. This fragile architecture cannot withstand the intense forces of a fast spin, so the entire aggregate deforms, bulging at its equator and flattening at its poles. This tells us something profound about its internal strength, or rather, its lack thereof. Varuna has very little structural integrity. It is a world of fragments, a celestial gravel pile whose shape is dictated entirely by the balance between its weak gravity and the powerful spin trying to tear it apart. How does this compare to the dramatic distortion of Haumea? While both are stretched by rotation, their stories diverge. Haumea's spin is believed to be the result of a single, cataclysmic impact that set the entire world spinning and created its family of moons. Varuna's rapid rotation, however, might be a more primordial feature, a spin inherited from the chaotic collisions and interactions that built it in the first place. Studying Varuna gives astronomers a crucial data point. By measuring its spin and calculating its resulting elongation, they can work backward to estimate its density and internal composition. A world that deforms so easily must be largely composed of water ice and porous rock, a fragile testament to the gentle forces that assembled the building blocks of our solar system. In this way, every rapid rotator we find adds another piece to the puzzle, revealing the hidden spectrum of strength and fragility among these ancient icy worlds. Even the most careful measurements can lead us astray in the distant solar system. Take the object named Ixion, a wanderer currently orbiting in the realm of the giant planets between Saturn and Neptune. It belongs to a class called centaurs, icy bodies that behave like a cross between asteroids and comets. Yet Ixion is widely believed to be a refugee, an object that originated in the Kuiper Belt and was later scattered inward by Neptune's gravity. This makes it a tantalizing proxy, a piece of the distant belt we can study from a little closer to home. But Ixion guards its true nature with a frustrating trick of light. Its size has been a moving target for astronomers. Initial observations suggested it was quite large, but that estimate was based on its brightness. You see, there are two ways an object can be bright. It can be genuinely large, or it can be small but have an extremely reflective surface. For a long time, we did not know which was true for Ixion. Was it a giant with a dark, sooty coat, or a smaller world painted a brilliant white? More recent data from powerful observatories like the Herschel Space Observatory have helped narrow it down, pointing toward a darker, moderately sized world. But the mystery of its surface composition only deepens with this revelation. Spectroscopic studies have revealed the presence of very dark, complex organic compounds and a surprising hint of water ice. This is a strange combination. How does a relatively dark object retain patches of water ice? The answer may lie in its recent journey. As a centaur pulled inward from the cold Kuiper Belt, Ixion is experiencing a new environment. The increasing warmth from the sun could be triggering chemical changes on its surface, a process we might be witnessing in real time. Perhaps it is undergoing a slow transformation, its ancient ices beginning to react in the slightly stronger sunlight, creating new, darker materials even as patches of its original surface remain. Ixion is a shapeshifter, not in form but in identity, a world caught between two homes and refusing to be easily classified. The serene waltz of binary worlds holds a secret stranger than any solo traveler. We find pairs where one member is painted a deep, rusty red while its partner shines with a cold, neutral blue. How can two objects locked in the same gravitational embrace for billions of years wear such radically different colors? This cosmic contradiction is perfectly embodied by the binary system 2001 QW322. Its two components are nearly identical in size, orbiting each other at a vast distance, yet their surfaces tell two completely different stories. The leading red component is classic, its color the expected result of cosmic radiation cooking methane ice into complex tholins over eons, but its blue twin is an anomaly. That steely blue-gray hue suggests a surface largely devoid of those complex organics, a landscape dominated by pristine water ice. The mystery is profound. If these two bodies formed together from the same cloud of material, they should have started with the same ingredients and been exposed to the same environmental conditions. They should be twins, not opposites. Their divergent colors scream of dramatically different life experiences. One possibility is that they did not form together at all. Perhaps this is a case of gravitational capture, a rare event where two independently formed objects from different parts of the primordial disk were snared by each other's gravity. One could have originated in a region rich in methane, while the other formed in a zone where water ice was the dominant surface material. Another, more dynamic theory involves resurfacing. Maybe the blue member suffered a recent massive impact that completely scoured its surface, blasting away its ancient, reddened crust and exposing a fresh layer of underlying water ice. In the slow-motion time of the Kuiper Belt, a few 100 million years is not enough for radiation to repaint that fresh surface its signature red. So we are left with a celestial partnership where one world bears the ancient wrinkles of age, while the other displays the bright scars of youth. Their shared orbit is not just a dance of gravity, but a silent argument between two conflicting histories. Orcus moves in a mirror image of Pluto's own dance with Neptune. This distant dwarf planet, often nicknamed the anti-Pluto, shares the same 2 to 3 orbital resonance, completing 2 orbits around the Sun for every 3 of Neptune's. But while Pluto and Neptune are locked in a gravitational pas de deux that keeps them forever apart, Orcus performs the same steps on the opposite side of the solar system. When Pluto is at its closest to the Sun, Orcus is at its most distant and vice versa. They are cosmic counterweights, 2 worlds bound by the same rhythm yet separated by an immense fixed gulf. This synchronized opposition is no coincidence. It is a stable configuration enforced by Neptune's gravity, a celestial balance that has likely persisted for billions of years. But Orcus is more than just an orbital mirror. It possesses its own compelling mysteries. It is accompanied by a comparatively large moon, Vanth, which orbits it in a slow, stately waltz. Vanth is unusually bright, and its color is different from Orcus itself, suggesting it may be a captured object from elsewhere in the Kuiper Belt, a foreign moon gravitationally adopted in the deep past. The surface of Orcus adds another layer of intrigue. Spectra reveal the clear signature of water ice, a common sight in the outer solar system, but there are also tantalizing hints of something more exotic, ammonia hydrate. This mixture is a potent antifreeze. On a world as small and cold as Orcus, the presence of ammonia mixed with water ice dramatically lowers its melting point, raising the astonishing possibility of a slushy, viscous cryomagma lurking just beneath the surface. Could this mean that Orcus, a frozen relic in a stable, predictable orbit, has experienced recent geological activity, with icy volcanism oozing this cold slurry onto its surface? The anti-Pluto may not just mirror Pluto's orbit, it might also echo its potential for hidden, dynamic life. The orderly clockwork of our solar system breaks down completely when we look at the most extreme wanderers. Far beyond the scattered disk, in a region of near-total detachment, exists a class of objects so alien in their movements they seem to belong to another star. These are the extreme trans-neptunian objects, and their orbits are unlike anything else we have seen. They are not just far away, they are profoundly isolated, with paths so hugely elliptical and steeply tilted that the giant planets, especially Neptune, have virtually no gravitational influence over them. They are celestial renegades operating under a different set of rules entirely. The object known as 2012 VP 113, nicknamed Biden, is a perfect example of this profound detachment. Its orbit never brings it closer than about 80 times the Earth-Sun distance, a gulf so vast that Neptune is a faint, irrelevant speck. Yet its most telling feature is not its distance but its angle. Biden's orbit is tilted sharply away from the flat plane where all the planets reside. This is the true signature of the Ethno, a cluster of orbits that are not only distant but also share similar dramatic tilts. This clustering is the crucial clue. In the random chaos of the early solar system, we would expect these extreme orbits to be oriented in all different directions, like a scattered handful of pencils dropped on a floor. Instead, we find them mysteriously aligned, as if an invisible hand has gathered them and pointed them in a similar direction. This precise, unnatural alignment is the strongest indirect evidence we have for the existence of a massive, undiscovered planet. The hypothetical planet 9, with an orbit thousands of times farther from the Sun than Earth's, would exert a slow, persistent gravitational torque over millions of years. Its immense pull could shepherd these detached worlds, herding their orbital paths into the clustered, tilted configurations we observe. These extreme objects are not just curiosities, they are the gravitational fingerprints of a hidden giant, tracing its path across the sky we cannot yet see. The gravitational partnerships we find in the Kuiper Belt can be deeply unequal, and none demonstrate this more starkly than the system of Salacia. This dwarf planet is locked in orbit with its moon, Actea, but this is no minor companion circling a giant primary. Actea is enormous, a moon so large relative to Salacia that it forces us to rethink how such cosmic pairs are born. The two worlds are nearly the same size, with Actea measuring roughly half the diameter of Salacia itself. This creates a system where the moon possesses a staggering 1/20th of the total system's mass, a mass ratio far higher than almost any other known binary in this distant region. Our standard models for moon formation struggle to explain such a balanced duo. A giant impact like the one thought to have created Earth's moon would likely have produced a much smaller secondary object. Gentle gravitational collapse from a single cloud of debris should have created two components of nearly identical size. So what process could leave one partner so dominant without the other being completely absorbed? The answer points toward a violent and specific kind of collision in the early Kuiper Belt, one that was both disruptive and incomplete. Imagine a glancing blow between two large, nascent planetary embryos. Instead of one shattering the other or merging completely, the impact could have stripped a colossal fragment from one of the bodies, a fragment that was then captured into orbit. This would create exactly the kind of mismatched pair we see with Salacia and Actea, a primary world with a massive chunk of its own body now circling it as a moon. The existence of this system suggests the early Kuiper Belt was a far more energetic and chaotic place than we once believed, a realm where colossal bodies frequently collided in ways that left behind these strange, unbalanced families. What other relics of these ancient, world-shattering crashes are waiting to be found, each one a frozen monument to the violence that built our solar system's outer frontier? Even our most powerful telescopes face a fundamental limit when peering into the Kuiper Belt, creating a profound observational puzzle. Our surveys have catalogued thousands of objects, yet there is a startling and consistent gap in the population. We are missing the small ones. According to long-standing models of how planetary systems evolve, the Kuiper Belt should be teeming with countless tiny, faint worlds, the predictable debris from billions of years of collisions. These models describe a collisional cascade, a continuous process where larger objects smash into each other, breaking down over eons into a vast population of ever smaller fragments. The predicted curve of size versus number is clear. There should be exponentially more small objects than large ones, but our actual observations paint a very different picture. The expected swarm of city-sized and mountain-sized Kuiper Belt objects simply is not there. The drop-off in numbers for smaller, fainter objects is far steeper than any collisional model can explain. So where did they all go? One possibility is that our technology is still the issue. Detecting these faint, distant specks is like trying to spot a single candle flame from a continent away. Perhaps the vast majority of small KBOs are just beyond the sensitivity of our current telescopes, and future observatories will finally reveal this hidden multitude. But many scientists suspect the truth is more fundamental, that the deficit is real. This would mean our entire understanding of the Kuiper Belt's formation and history is incomplete. If collisional grinding was not the dominant process, what was? The answer might lie in a much gentler origin story. Perhaps the primordial building blocks of the Kuiper Belt were not dense, solid bodies, but incredibly fragile aggregates of dust and ice like cosmic snowballs. When these fluffy structures collided, they would not have shattered into a cascade of sharp fragments. Instead, they may have simply merged, sticking together softly and quietly, absorbing impact energy without generating the expected clouds of small debris. This gentle accumulation would have left behind a belt that is inherently deficient in small objects, because the violent fragmentation required to create them never occurred on a large scale. The missing small KBOs are not just an empty census, they are a silent testament to the delicate and surprisingly peaceful assembly of our solar system's outer frontier. Amidst the gray outliers and pale ice worlds, one wanderer stands out for its cloak of profound darkness. 2007 or 10 is one of the reddest objects in our entire solar system, a deep, blood-rust hue that speaks of immense age and relentless exposure. Its color is not a simple stain, it is a chemical clock ticking away over billions of years. This intense redness is the signature of tholins, the same complex organic sludge we find on Arrokoth, but here the process has run for an unimaginably long time. The surface of Orten is dominated by methane ice, a volatile substance that should readily vaporize and escape from an object of its size. Yet there it sits, a vast reservoir of frozen methane being constantly bombarded by cosmic rays and the faint, distant solar wind. This relentless radiation shatters the simple methane molecules, breaking them apart and reassembling them into ever more complex, long-chain polymers that reflect only the deepest red light. The sheer intensity of its color suggests this world has been sitting in this same distant, cold environment for eons, its surface processing so slowly and so completely that it has become the definition of an ancient, unaltered landscape. It is a fossil in the most literal sense, its very skin a record of billions of years of cosmic weather. But this story of solitude was recently appended by a stunning discovery. Careful analysis of archival data revealed that Orten is not alone, it is accompanied by a small moon. This companion, now named Quaoar, forced astronomers to recalculate everything they thought they knew. By measuring the moon's orbit, they could suddenly calculate the system's mass, and the result was a shock. 2007 Orten is much more massive than its dim, red appearance suggested. This means its density is surprisingly high, indicating a much rockier interior than anyone predicted for such a brilliantly red world. How does a world with such a thick, ancient crust of processed methane ices hide a dense, rocky heart? The presence of its moon deepens the mystery, pointing to a violent collision in the deep past that may have both provided the rocky material and blasted a moon into existence. This dark red giant is not a simple monolith, it is a complex system whose colorful skin hides a tumultuous history written in rock and ice. While many Kuiper Belt objects are chaotic wanderers, one group remains in serene, undisturbed orbits. These are the cold classicals, a population of worlds that have followed the same quiet, circular paths for 4.6 billion years. Their name comes not from temperature, but from their calm dynamics. Unlike the scattered and resonant objects flung about by Neptune, the cold classicals have nearly perfect circles for orbits, gliding along the solar system's original plane with minimal tilt. This peaceful existence makes them the true primordial relics of our solar system, time capsules frozen in place since the very beginning. Their surfaces tell the same ancient story, displaying a remarkably uniform and deep red color. This is the deepest red hue found anywhere in the Kuiper Belt, a sign of tholins that have been cooking under cosmic radiation for eons without interruption. No giant impacts have scarred them, no gravitational encounters have stirred them up. They have simply been sitting in the deep freeze, their surfaces processing so slowly and completely that they have become a standard for primordial redness. But their most telling feature might be how many of them come in pairs. The cold classicals have the highest fraction of binary systems of any population in the Kuiper Belt. These are not moons captured by chance, but twins born together from the same cloud of dust and ice. Their delicate gravitational bonds could never have survived the violent chaos that reshaped the rest of the outer solar system. Their very existence, dancing peacefully in the darkness, is proof that a quiet corner of the primordial disk survived untouched. When we look at a cold classical object, we are not looking at a transformed or scattered refugee. We are looking directly at one of the original building blocks of our planetary system, a piece of the solar system's original construction material that was never used, left in its factory-sealed condition in the cold storage of deep space. What secrets about our own planet's ingredients are locked within these pristine, crimson worlds? The presence of methane on a small, cold world like Haumea is a paradox that defies simple chemistry. This dwarf planet candidate, drifting in the scattered disk, bears the spectral fingerprints of both water ice and methane on its surface. For scientists, that methane is the central enigma. At Haumea's vast distance from the Sun, the feeble warmth it receives should have stripped this volatile ice away eons ago. Methane, much like dry ice on Earth, has a tendency to sublimate, transforming directly from a solid into a gas when exposed to even minimal heat. Over billions of years, any primordial methane on a small body like Haumea should have boiled off into the vacuum of space, leaving behind a barren surface of water ice and rock. Yet the data insists it is still there. How can this be? The answer may lie in a process of continual renewal. One compelling theory suggests that Haumea could be experiencing a form of cryovolcanism. Deep beneath its frozen crust, residual heat from the decay of radioactive elements, or perhaps the lingering warmth from its violent formation, might be sufficient to occasionally mobilize pockets of subterranean methane. This material could then erupt onto the surface in slow, oozing flows, constantly repainting the landscape with fresh frost and replenishing what is lost to space. Another possibility is that the methane is not free at all but trapped. It could be locked away in a crystalline cage of water ice, forming a stable compound known as a methane clathrate. This icy prison would act as a cosmic deep freeze, preventing the methane molecules from escaping. Only when the surface is disturbed, perhaps by a micrometeorite impact, would small amounts of this trapped methane be exposed and detected. Haumea's methane is more than a spectral line. It is a clue pointing to a hidden, dynamic world, one that may still be geologically alive against all odds. What other volatile secrets are being guarded by these distant, icy sentinels? The clockwork precision of our solar system is written in the gravitational relationships between worlds. Far from being random, entire populations of Kuiper Belt objects are locked in rhythmic dances with Neptune, their orbits governed by precise mathematical ratios. These are the resonant populations, and their synchronized paths are a direct recording of the solar system's most turbulent era. The most famous of these are the Plutinos, objects like Pluto itself that are trapped in a 3-to-2 resonance with Neptune. For every 2 orbits Neptune completes, a Plutino completes exactly 3. This celestial rhythm creates a stable, repeating pattern that ensures the objects never get too close to the immense gravity of the ice giant. But there are other, rarer harmonies. The 2 Tinos, for instance, exist in a 2-to-1 resonance, making 1 orbit for every 2 of Neptune's. This rhythm is far less common, suggesting a different history of capture. How did these distant worlds fall into such perfect step with a planet billions of miles away? The answer lies in a grand migration. In the early solar system, Neptune did not form where it is today. It slowly drifted outward from the Sun, and as it moved, its powerful gravity swept up countless icy bodies, herding them into these stable, resonant orbits like a shepherd guiding sheep into a pen. The very existence and distribution of these resonant populations allow us to rewind the tape. The large number of Plutinos compared to the sparse 2 Tinos tells a detailed story about the speed and smoothness of Neptune's migration. A slow, gentle drift would have captured more objects into a wider range of resonances. The fact that we see such a strong preference for the 3-to-2 resonance suggests Neptune's movement may have been more abrupt, a series of jumps and pauses that favored the capture of Plutinos above all others. Each of these twirling worlds is a fossilized echo of Neptune's ancient journey, a celestial metronome still ticking to the rhythm of a planetary dance that began over 4 billion years ago. Its surface tells a story written in charcoal, not ice. Among the frozen, reddish worlds of the Kuiper Belt, 2004 EW95 stands out as a stark, dark silhouette. This is no ordinary resident of the deep freeze. When astronomers first analyzed its spectrum, they found the unmistakable fingerprints of carbon, a chemistry that belongs to the warm, rocky inner solar system. This object is a C-type or carbonaceous asteroid, the same kind of primordial, sooty material that makes up much of the asteroid belt between Mars and Jupiter. Its presence in the Kuiper Belt is like finding a piece of tropical coral embedded deep in an Arctic glacier. It simply does not belong there. How did a body that clearly formed in the searing heat close to the Sun end up stranded in the coldest, most distant part of our planetary system? The answer paints a vivid picture of the solar system's chaotic infancy. This dark wanderer is a piece of direct physical evidence for the Grand Tack model, a theory that describes a dramatic reshuffling of the planets. In this early era, the giant planets, particularly Jupiter and Saturn, were not the stable guardians they are today. They migrated, moving inward and then outward through the disk of primordial material. As they lumbered along their new paths, their immense gravity acted like a cosmic paddle, churning the entire solar system. They flung countless inner solar system objects, rocky bodies like 2004 EW95, on desperate outward trajectories. Some were ejected into interstellar space forever, while others, like this one, were hurled just far enough to be captured by the growing Kuiper Belt, stranded billions of miles from their birthplace. This carbonaceous intruder is more than a curiosity, it is a refugee. Its dark, carbon-rich composition is a permanent tag, labeling it as an immigrant from a warmer, more violent neighborhood. Finding it so far from home confirms that the early solar system was not a placid, orderly place. It was a cosmic shooting gallery, a realm of gravitational chaos where entire populations of worlds were violently evicted and relocated. This single, dark speck of carbon is a frozen testament to that epic journey, a permanent exile holding the secret to the solar system's most turbulent chapter. This grandest of all Kuiper Belt mysteries is not an object we have seen, but one we can feel. The gravitational whispers of a hidden giant are etched into the clustered paths of the most extreme trans-neptunian objects. Their strange, tilted orbits are not random. They point with one voice toward the existence of a massive world, a hypothetical planet 9 orbiting in the profound darkness. The statistical chance that this orbital alignment is a coincidence is astronomically small. These distant wanderers are like iron filings scattered on a table, all suddenly aligning to point toward an invisible magnet. The evidence suggests this unseen planet is substantial, a super-Earth up to 10 times the mass of our own world, on an orbit so vast it would take 10 to 20,000 years to complete a single journey around the Sun. At its closest approach, it would still be hundreds of times farther from the Sun than Earth, a dim, cold realm where the Sun is merely the brightest star in a perpetual night sky. Its composition would likely be a frozen mix of rock and ice, a captured core of a gas giant that failed to form, or perhaps a rogue planet snatched by the Sun's gravity in its distant youth. The hunt for this phantom world is one of astronomy's greatest modern quests. Teams of scientists are using the world's most powerful telescopes, like Subaru in Hawaii, to scan the predicted swath of sky where this planet might be lurking. They are looking for a single, faint pixel of light moving imperceptibly slowly against the backdrop of fixed stars. The challenge is immense, as the object would be incredibly dim and its motion across the sky glacial. Yet the potential reward is the redefinition of our solar system. Confirming Planet 9 would be a discovery on par with finding a new continent on a map we thought was complete. It would explain the orbital chaos at the system's edge and rewrite the story of our solar system's formation and architecture. Is this hidden world truly out there, a dark giant waiting to be found, or is its ghostly signature merely a flaw in our understanding of gravity itself? The answer lies in the silent, patient search of the deepest sky. From flattened cosmic pancakes to the gravitational whispers of a hidden world, these 25 objects reveal a frontier of staggering diversity and profound mystery. Each one is a unique piece of a grand cosmic puzzle, a clue frozen in time that helps us reconstruct the violent and dynamic history of our solar system's formation. The gentle merger of Arrokoth shows us the quiet beginnings, while the chaotic orbits of the scattered disk scream of a gravitational war waged by migrating giants. Haumea's violent spin and Quaoar's impossible ring challenge our fundamental laws, and the deep red of the cold classicals offers a glimpse of the primordial ingredients from which all else was built. Every strange shape, every unexpected color, and every impossible orbit is a testament to a more complex and wondrous story than we ever imagined. This is not a static museum of frozen relics. It is a dynamic archive of our cosmic past, and the search is far from over. The next great leap in understanding is already on the horizon with missions like the Vera C. Rubin Observatory, which will soon begin scanning the skies to discover thousands more of these distant enigmas. Each new discovery will add another piece to the puzzle, bringing us closer to answering the biggest questions of all. So as you look up at the night sky, remember the mysteries swirling in that profound darkness. Which of these cosmic enigmas captured your imagination the most? Was it the lonely journey of Sedna, the hidden ocean of Pluto, or the ghostly pull of Planet 9? Let us know in the comments, and never stop looking.